Welcome to this video on mass, weight, and gravity. We'll cover the essential concepts you need to know for your physics exam. In this video, we'll break down the definition of mass, the concept of weight, and the role of gravity. We will also look at the relevant equations and some key exam tips. Let's begin with the basics. What exactly is mass? And why is it important? Mass is the amount of matter in an object. Whether it's a grain of sand or a blue whale, mass measures the atoms and particles it contains. It's a scalar quantity, meaning it has size but no direction. Mass is measured in kilograms. While smaller units like grams exist, kilograms are the standard for GCSE. Remember, a balance measures mass, and it is not measured in newtons. Crucially, mass is constant. Your mass stays the same whether you are on Earth, the Moon, or in deep space, because the number of atoms in your body remains unchanged. Now let's explore weight and how it differs from mass. Weight is the force exerted on an object due to gravity. As a force, it's a vector quantity with both magnitude and direction, always acting downward towards the center of a planet. Weight is measured in newtons. We use a Newton meter or spring balance to measure it. Unlike mass, weight depends on the gravitational pull of your location. This table summarizes the differences. Note that mass is scalar and constant, while weight is a vector force that changes with location. Next, we move on to gravity. What is it, and how does it give objects weight? Gravity is a non-contact force of attraction between objects with mass. It keeps planets and moons in orbit, and is the reason objects fall to the ground. Because gravity is a non-contact force, it works over distances through a gravitational field. This field allows one massive object to exert force on another without physical contact. Gravitational fields are strongest near the source. Earth's field holds our atmosphere, while the moon's weaker field creates tides. Satellites remain in orbit by balancing speed and this gravitational pull. Finally, gravitational field strength, denoted by measures how strong gravity is at a location in newtons per kilogram. On Earth, G is about 9.8, while on the moon, it is much lower. Gravitational field strength varies throughout the solar system. While mass remains constant, your weight changes significantly depending on where you are. Understanding the weight equation is essential. It is the most important formula in this topic, so make sure to learn and practice it. The formula is weight equals mass times gravitational field strength. In symbols, W equals m times g. Remember that units must be consistent. Mass in kilograms and gravitational field strength in newtons per kilogram result in weight in newtons. Let's look at an example. To find the weight of a 60-kilogram student on Earth, multiply their mass by 9.8. This gives a result of 588 newton. If that same student travels to the moon, where the gravitational field strength is 1.6, their weight drops significantly to 96 newtons. Their mass, however, remains 60 kilograms. In exam questions, you may need to rearrange this equation to find mass or gravitational field strength. A formula triangle can be a very helpful tool to remember the correct arrangement. For instance, to find mass, divide weight by gravitational field strength. If an object weighs 49 newtons on Earth, dividing by 9.8 gives a mass of 5 kilograms. Always remember that while your weight fluctuates based on your location and gravity, your mass is an inherent property that never changes. Consider a 10-kilogram rock. On Earth, it weighs 98 newtons. On the Moon, that weight drops to 16 newtons. And on Jupiter, it surges to 248 newtons. The mass remains 10 kilograms throughout. On Earth, the standard gravitational field strength is 9.8 newtons per kilogram. Sometimes, exam papers simplify this to 10 for easier calculations, so always check your specific paper. The Moon has a much weaker gravitational pull because it is less massive and smaller than Earth. Its field strength is only about 1/6 of our own. The Moon's weaker gravity is due to its lower mass and smaller physical size. These factors combine to create a much lower surface gravity compared to Earth. To summarize these values, Earth's field strength is 9.8, the Moon's is 1.6, Jupiter's is 24.8, and Mars's is 3.7. Note the differences based on the planet's mass. Gravity influences many things, from the acceleration of falling objects to maintaining satellite orbits and causing ocean tides. Finally, avoid common mistakes. Weight is measured in newtons, not kilograms. Remember that mass is constant. Use correct terminology for G, and always rearrange your equations carefully. When answering exam questions, units are vital. Mass must be in kilograms and weight must be in newtons. A correct numerical answer without the right unit will often result in 0 marks. Let's practice. If a box has a mass of 25 kilograms, we calculate its weight on Earth using the formula weight equals mass times gravity. Multiplying 25 by 9.8 gives 245 newtons. For our second example, an 80-kilogram astronaut has different weights based on location. On Earth, they weigh 784 newtons, but on the Moon, they weigh only 128 newtons. Their mass remains constant. In this scenario, a probe weighs 370 newtons on Mars with a gravity of 3.7. By rearranging the formula to mass equals weight divided by gravity, we find the mass is 100 kilograms. Let's check your knowledge. Can you identify the units for mass and weight, define the gravity formula, confirm if mass changes on the Moon, and categorize the type of force gravity is? Here are the key definitions at a glance. Remember, mass is the amount of matter, weight is the gravitational force, gravity is the non-contact attraction, and gravitational field strength is the force per unit mass. Looking at the big picture, all these concepts connect. Weight is fundamentally the result of mass experiencing a specific gravitational field. Follow these final tips for your exam. Always write the formula first, check your units every time, remember that mass is constant, and memorize common values for Earth and Moon gravity. This summary table highlights the differences between mass and weight, the core equation, and the variation in gravitational strength between the Earth and the Moon. You're now ready for your exam. Remember, mass in kilograms, weight in newtons, and the formula is W equals m times g. Good luck!